This is Chapter 7, Section 6, Objective Functions. Example 1, you have to find the minimum and maximum values of the objective function and where they occur, subject to the indicated constraints. The graph of the region is determined by the constraints provided. The objective function is z equals 3x plus 5y. The constraints x plus y is greater than or equal to 2, 4x minus 5y is less than or equal to 8, and negative 2x plus 7y is less than or equal to 14. To graph, you have to set all the constraints to y equals. So for the first equation, it would be y is greater than or equal to, and you just move the x over, so it'd be negative x and then plus 2. For the next one, you would get y is greater than or equal to 4/5 x minus 8/5. And it's greater than because you have to divide by negative 5. Now the next one is y is less than or equal to 2/7 x plus 2. Now for this first graph, it is negative x plus 2. So we're going to graph 2. And it's negative 1 over 1, negative 1 over 1. And you just draw the line. Okay, and since it's y is greater than or equal to, you can plug in a point that's not on the graph. So 0, 0. So 0 greater than or equal to 2, and it is not. So you shade the other side. So you'd shade like this. Okay. Next, for this one, you have to graph negative 8/5 is the y-intercept. So that's about there. And then 4, 1, 2, 3, 4, 2, 3, 4, 5. I'm going to graph it like this. Now a point that's not on the line to test for greater than or equal to is 0, 0. So 0 is greater than or equal to negative 8/5. And it is greater than, so you shade the region with 0, 0 in it. And for this equation, we need 2 for the x-intercept, or y-intercept. And then it's 2, 7, so 1, 2, 1, 2, 3, 4, 5, 6, 7. Another point would be right here. So it's going to come in through there. And to test, 0, 0 is 0 less than or equal to 2, and it is, so you shade down. And you have to find where they all occur at the same time, so that would be here. And the vertices for that would be 7, 4, 2, 0, and this is 0, 2. I'll write that again over here. 7, 4, 2, 0, and 0, 2. Now to find the minimum and maximum points, or minimum and maximum values, you have to plug in the vertices and do the objective function. So we have the vertices of 0, 2, 2, 0, and 7, 4. And you have to plug these into the objective function. So if you recall back, it was z equals 3x plus 5y. Now, for the first 1 to find the value, we would take 3 times 0 plus 5 times 2. And for this, we're just plugging these into the objective function, and that gives you 10. Now for the next one, it was 2 plus 5, 0 equals 6. And the final one gives you 3 times 7 plus 5 times 4, and that gives you 41. So we know that this is the greater value, and this is the smallest value. So in that case, the minimum value is at this point and this point, so it would be at 2, 0. And the maximum, which was 41, gives you 74, so it's 0.74 right there. And that's how you find the minimum and maximum values of the objective of a function.
Okay, a factory can produce two products, X and Y, with a profit approximated by P equals 13X plus 20Y minus 900. The production of Y can exceed X by no more than 200 units. Y is less than or equal to X plus 200. Production levels are limited by the formula X plus Y is less than or equal to 1,000, which is equal to Y is less than or equal to negative X plus 1,000. The other two constraints are X is greater than or equal to 0 and Y is greater than or equal to 0. And these are in place because production levels cannot be negative. Now we need to graph those functions. The X is greater than 0 and Y is greater than or equal to 0 don't actually show up on the graph, so you don't need to physically graph those. The Y is less than or equal to negative X plus 1,000 has a y-intercept of 1,000, and it goes down at a rate of negative X. And since it's less than, I have to shade down, so all this. Y is less than or equal to X plus 200, has a y-intercept of 200, and it goes up at X, so, and it's less than, so you shade down. This section is overlapping all the equations. It has vertices of 400, 600, 0, 200, 0, 0, and 1,000, 0. You have to then plug those coordinates into the objective function of P equals 13x plus 20y minus 900. So 13 400 plus 20 times 600 minus 900 equals 16,300. 13 times 0 plus 20 times 200 minus 900 equals 3,100. And 13 times 1,000 plus 20 times 0 minus 900 equals 12,100. 16,300 is the max value, and 3,100 is the minimum value, so meaning that the point 400, 600 is the maximum value, and 200. 0, 200 is the minimum.